Let's take a look at another example here of partial fractions. So we have this rational function here. We can go ahead and factor the bottom. So this would factor out to be x minus 2 times x minus 1 on the bottom. And x minus 3 on top. I think probably the number one mistake with any of these problems is the factoring. So don't go too fast. Make sure we're checking. Make sure we multiply our factors back together to see if we get the same answer on the bottom. So we're going to go ahead and split this up into two fractions because we have two factors on the bottom. So we have a over x minus 2 plus our b value, and that is going to be over x minus 1. So we go ahead and we multiply both sides by the common denominator, so it would cancel out on the left hand side there. We would have to multiply this fraction by the common denominator so that x minus 2's would cancel out. So we have a times x minus 1. So a times x minus 1. I'm going to go ahead and distribute that in. So we have ax minus a. Sorry, 2a. No, a. That was right. And then we have this fraction, the x minus 1's cancel out, so b gets multiplied by x minus 2. So we're going to go ahead and distribute that in. So we get plus bx minus 2b. And we go ahead and group like terms together, so ax and bx would go together, and I would factor out an x. So we have a plus b times x. And then we have these together. We have a negative a and a negative 2b. All that equals x minus 3. And we're going to go ahead and we're going to look what matches up. So the number in front of x over here is a plus b. The number in front of x over here would be 1. So we're going to go ahead and put those together. So a plus b equals 1. And we have this constant term on the right, constant term on the left. So we have a negative a minus 2b equals negative 3. So now we've created a system of equations, so two variables and two equations. We can go ahead and substitute or eliminate. I'm just going to go ahead and add these two functions because we can eliminate the a value if we do that. So we're adding, so let's 0. We get a negative b and a negative 2. So b would equal positive 2. We have our variable value, so we can go ahead and plug it into one of these two equations. I think the top one is going to be the easiest. So we have a plus 2 equals 1. So a is going to have to be a negative 1. Now you could set up it over here and solve it out, but you guys are all good enough at algebra to think about it. So we have a is negative 1, b is 2. So we're going to go ahead and plug it back into that. So as an integral. So we have negative 1 over x minus 2 plus 2 over x minus 1. So now we can integrate separately the fractions. So we end up with integral of this first one would be negative natural log of x minus 2 plus 2 times the natural log of x minus 1 plus c. Alright, so that's how we handle partial fractions. Let's go ahead and take a look at one more example here, and then I'm going to post another video on something else about partial fractions. So let's go ahead and factor this out. So we know we can take an x out of all of these. Remember, whenever we're factoring, we start with greatest common factor first. So I would take an x out front, and we're going to be left with x squared minus x minus 2. So we can factor that out to be x minus 2 and x plus 1. Split it up, and we're going to have 3 fractions this time because we have 3 factors. So we have a over x plus b over x minus 2 plus c over x plus 1. Okay. Now again, we're going to multiply by the common denominator to everything, all the terms, both sides. So we're left with 12. Actually, I want to move that over. So 12 equals, this fraction, x's would cancel. We're going to multiply by both of these. So I'm going to put that back together. And then multiply by a. So we have a times a squared. We have negative ax, and we have a negative 2a. The b, x minus 2's cancel, so we're going to multiply by x and x plus 1. So we're going to get bx squared. We're going to get bx. And then this fraction, x plus 1's cancel, so we're going to multiply by those two, x and the x minus 2. So we're left with cx squared minus 2cx. So now we group like terms together and pull the common factor out. So we have 3x squared terms. So we have c plus b plus c. So a plus b plus c. Okay. And that's our x squared term. Pulled that out, and now we have a negative ax, bx, and a negative 2cx. So we can go ahead and take those out. So we have a negative a, we have plus b, and a negative 2c. And again, that's our x term, and then we all have one constant term here, the negative 2a. So we put that at the end. Okay, so this one's different because we have an x squared term, we had 3 fractions, and it's a little different because we don't have any x's over here, we just have a constant value. So when we're setting up our equation, so we're looking for an x squared. The number in front of x squared is a plus b plus c. The number over here in front of x squared, well, there is no x squared, and so we would put 0. So we have a 0x squared over here. So when we're writing out our system of equations, we have a plus b plus c equals 0. Our x coefficient, there's a 0x over here, and we have this. So this is going to be set equal to 0 as well. That's equal to 0. And then our constant term gets set equal to our constant term. So negative 2a equals 12. So we can find out what a is pretty easily in this one. So we have a equals negative 6. If I were to take these two equations and add them, a's would cancel. So I'm going to write that down here. So let's add these up. We have 0a, we have 2b, and minus c equals 0. Okay. So we know we have 2b equals c. And now what I'm going to do is I'm going to take our c value and our a value, plug it back into the first equation. So we know a is negative 6. We know b, well, we don't know b. That's what we're trying to find. B, and then our c is 2 times b equals 0. So we have 3b equals 6. B equals 2. So now if I have a negative 6 plus 2, that's negative 4. How do I get 0? Well, C has to be 4. So now I have all of our fractions here. So when we go ahead and we rewrite our integral, we're going to go a, which was negative 6 over x. So make sure we're keeping these in the same order too. So always look back and see which variable was over what factor. So b is 2 over x minus 2, and c was 4 all over x plus 1. Now we can go ahead and integrate these separately, and we're going to use natural log on these, just like we have done in the past couple examples. All right, so let me know if you have any questions. This is kind of a lengthy process, but it's a good practice for your algebra skills. So let me know if you have any questions.